Hi everyone. So today we're going to look at lesson 12.5. So again, using a number line, but for this time, fractions that are greater than one instead of less than one like we looked at before. Um, so the I can statement for this lesson is I can represent fractions equal to or greater than one on a number line. And when they say equal to one, they mean the fractions that say 2 over 2 and 3 over 3 and 4 over 4, because those all equal a whole. Those all equal 1. And we'll look at those more throughout this as they come up. I'll point out that those are like the whole fractions that those equal 1. So the solve and share says the length of one strip of paper is 1 whole unit. Right. Fold 2 strips of paper in half. Open the strips and have them place them end to end. Sorry, guys. Just wanted to get this. Can't do too many things at once here. How many halves do you have? How can you use halves to name the folded lines? Tell how you decided. Draw a picture to show your work. So here it says use appropriate tools. Think about how your paper strips show copies of unit fractions. So if you have a strip of paper at home and you haven't done this yet, you can get that strip of paper. You can create a strip of paper. Like a small strip of paper is totally fine. I'm going to show you how they folded it. If you were to have a strip of paper in front of you, well, maybe your strip of paper looks a little bit more neat than mine does, but that's okay. So it says the length of one strip of paper, this right here is 1 whole. Okay, this whole entire strip is 1 whole. From here to here is 1 whole. It then says, sorry, it's 1 whole unit, but still, just 1 whole. Fold 2 strips of paper in half. So you're folding this piece like in half. So I'm going to change colors. This would be like it in half. So I folded it in half. So this is 1/2, and then this is 1/2. And then it says, open the strips and place them end to end. But it's like first you had to fold it here, and then you also folded this one in half, and then this one in half. So pretending that we're going to use the top part is our number line. This would still be 0 because we started 0. This is 1/2. So this is 1 out of 2 pieces. And we're going to move on. This middle line is 2 out of 2. So again, this is the whole. This equals 1 because this is 2 out of 2 pieces. And instead of starting over, we're just going to keep going. This is 3 out of 2. And then this is 4 out of 2. So basically, the only thing I want you to pay attention to here, because I know this can be kind of confusing, especially since we aren't in person still, but we're still going to try and make it work as best as we can. So the number on the bottom stays the same the entire time. So the denominator, so I could say I use the total number of equal parts in 1 whole for the denominator and then counted the folds for the numerators. So I used like how many halves there were. So there were 2 halves, 1/2, 2/2. And then I folded them in lines again, which were here and here. And then I just kept this bottom number the same. But if you look at the top number, the numerator, just pay attention to that as well, because 1 piece, 2 pieces, 3 pieces, 4 pieces. So there's 4 pieces all together, and we kept the number the same at the bottom. We kept the denominator the same. Okay, it says, if you added a third strip of paper folded in half, how could you use halves to name the fold lines? explain. So because up here we had 4 halves, so there were 4 pieces total up here. So if we added one more strip of paper to the end, then it would go, the lines would go from like 0, we would start at 0 again, and then it would go from 1/2, and then we would have our 2, and then we would have our 3, and then our 4, and then our 5, and then our 6 halves, because we would just add on 2 more like pieces for, because this would equal one whole piece of paper, like one whole other little sheet. Because the blue rectangle I drew up above represented 2 sheets. I misspoke on that. So that was like 2 pieces put together, but then it was like how many halves are there all together, and then they counted the halves. Okay, we're gonna move on to the next page. It says, how can you use a number line to represent fractions greater than 1? So numbers that are more than 1, like representing, like whether it's 2, representing 1.5. Okay. I know you guys did measurement last year, so it's kind of, think about that when you did halves, or if you did 1.5 inches, or if you even looked at the 1/4 inch. Not entirely sure, but it's kind of similar to that in a way. It can also help you when we do measurement. So again, the essential question is, how can you use a number line to represent fractions greater than 1? Here it says, a bunny hopped 7/4 the distance of a trail. How can you show this on a number line? Number lines can also represent fractions that are greater than 1. So here it shows the cute little bunny, and then it shows how far it hopped, okay? And then here it says the whole is the distance between 0 and 1. So like how much the whole is. So basically, how far do we have to go until we can get, since the denominator is 4 for this, there's the 4 here and the 4 here and here, and even tells you right here the denominator is 4. Basically, when we have to find the whole and they give us the denominator, so this is the denominator right here, the bottom number. When they say, oh, like how far into the hole, how many jumps until you have to get to the hole, how many until it's 4/4? The whole is always going to be the bottom number and the top number are the same. That is the whole you are looking for. That is the whole you have to go to. So it says here, the numerator is 7. There are 7 lengths of 1/4. Sorry, because over here it says that this is 1/4 because 1, 2, 3, 4. There are 4 spots until you get to the hole, and this is in fourths. The numerator is 7. There are 7 lengths of 1/4. The point showing 7 lengths of 1/4 can be labeled as 7/4. So here, again, this 1 here equals 4/4. That 4/4, that is the whole right here, okay? So they want us to pay attention between the 0 and the 1 to find out how many spots there are. There's 1, 2, 3, 4, like I said over here. And then since we keep going, we keep the denominator the same. We're not going to change it. And then we'll just keep going. So then 5/4, 6/4 until we get to 7/4 or 7/4. So we are going to move down to the bottom. So it says here, one point on the number line below has been named with the fraction 2/3. On the number line, the lengths are marked are equal. Write a fraction for the other points shown. So I'm not even going to start with this one first. I'm just going to look at my 1, because if this is the denominator I'm working with, my 1 is automatically just going to be 3/3. And then count on 3/3, 4 over 3, 5 over 3. Boom. And then this one over here, 3, 2, 1 over 3, 1/3. And I know I'm saying like 4 over 3, 5 over 3, and like the correct way to when we're naming and talking about fractions would be 1/3. I'm just trying to do it, saying it in that way, so you know exactly what to write and just what it should look like. If you're like just listening to the video, or if it's not making sense when I'm drawing it out. But it would be 1/3, 3/3, 2/3, 4/3, 5/3. Okay. So those are the fractions that I would fill in and that you hopefully have filled in if you have been working on this. Go to the page. Okay, the guided practice. So right here, it says name a fraction that is to the right of the point for 2 on a number line. So I know that this question is kind of confusing, and I'm going to try and draw it out, but I'm just going to do it on the side. So for example, because it doesn't say like, oh, look at this question or anything else like some of the other ones have. So we're just going to do a number line here. This is my 0. I'll make this my 1. And then my 2 I'll put here. Okay, so I need a fraction that would be right here, basically. So if I were to do, say like this equals 4 over 4 right here. So this is 1/4, you get it, 2/4, 3/4. And then after this would be 5/4, sorry, 6/4, 7/4. And then this 2 equals 8/4. Because also if you look at it, 8 divided by 4, 2. That's another way to do it. 4 divided by 4, 1. It works for our like wholes, not our numbers in between. When you get to a whole, it definitely works for that. So the next one would be after 8/4 or 8 over 4 would be 9/4. And yeah, you could also have done this for like fifths or sixths even, or like thirds or whatever you want your denominator to be. I just wanted to use the 4 for mine. So for number 2, it says Quinn says that 10/8 comes to the right of 9/8 on a number line. Do you agree? Why or why not? So based off what I showed you here, if on the number line, if this is 9/8, they're saying what would go to the right of this? It would be 10/8. It's just what comes next. Okay, so yes, and then listen for the explanation because I cannot write it all out with this digital pen marker thing. So 10/8 has one more copy of 1/8 than 9/8, so that represents a longer length from 0. That was the explanation that the book gave, and I'm going to read it one more time, and then I'm also going to put it into my own words. So 10/8 has one more copy of 1/8 than 9/8, so it represents a longer length from 0. Or do you agree? Why or why not? Yes, because 10 comes after 9, because 10 is one more than 9. Okay, I don't need a full, like, super complicated explanation for this. Just, or you could, even if you were to say yes because, and then if you drew a number line like this or something similar, that's also fine because you guys know, hopefully by now, pictures are totally fine for an explanation because some of our brains work better that way. In 3 and 4, each number line has equal lengths marked. Write the missing fractions. So again, we are just looking at the bottom number for the rest of our bottom numbers. So I can go in and fill in my 3's as my denominators. What comes before 2? 1. What comes after 3? 4. Just basic counting for this. Then here, what does 1 equal if my bottom number is 4? 4 over 4. We know that that's our whole. We know that we're good to go. Comes next, 5 over 4, 5/4. Then 6 over 4, 6/4. 7 over 4, 7/4. And going back to the beginning, 1 over 4. And well, Miss Lynn, why did you just do the 1 over 4 first? Wouldn't have that just been easier for you? For me personally, no. That's why I just counted. I started like at a whole and moved forward. But however you choose to fill it in, as long as you're going along with what I'm doing here, totally fine. Whatever way you want to do it. I am going to erase this now, so pause it if you need to copy anything or change your answers or correct anything. Okay, and then moving down to the independent practice. So it says leveled practice, so like it'll get harder basically as you're moving on, or at least that's what they expect it to be. If it didn't get harder for you, that's totally fine. If all of it was pretty difficult, that's okay too. Or you're learning this, it's something you're working on. So it says in 5 through 7, each number line has equal lengths marked, right? The missing fractions. So for here, all you have to do is fill in this one. It's a pretty small number line. This one here, you look at your other fractions they give you. This is a 2. You can't really see that I circled it. You have it in front of you, hopefully. So I know that this then equals 2 over 2, or z over z, because it looks weird, but it's a 2 over 2. And then this here would be 1 over 2. And then again, my denominator here is also 2. I'm gonna try. Nope, still covered it. It's fine. So I know my denominator here will also be 2. So, and my 1 equaled 2 over 2 again. So the one I'm filling in this time is 3 over 2. Yes, these number lines are different sizes, but we still just need to pay attention to the numbers, like the actual numbers that they give us. So they gave us 3 like halves. Or 3 over 2. So we just have to pay attention that the 2 is the bottom number for this, and the 2 is the bottom number for this. It doesn't matter the size of the number lines. It just matters what the numbers that they have given us are. And for number 7, we start out at 1 over 1/6. So the next 2/6. Then if you're like, oh, is that right? How am I supposed to check? 3/6 comes next. 1, 2, 3. Okay. Then 4/6 and 5/6. Okay, cool. And the bottom says in 8 and 9, divide the number lines into equal lengths, write the missing fractions. So basically fill in the numbers that are missing for the whole thing. So I know here that this is 3 over 3. And since my denominator is 3, I'm breaking everything into thirds, 3 pieces. I have to have 3 spots between each whole number. Okay, so between 0 and 1, I have to put in my 1/3 because I have 1 space here, 2 spaces, 3 spaces, 3 whole spaces. Next, I'm going to draw my 2 lines because then I already know I have 1 space. Make it a thicker line so you know it's my coloring in. 1 space, 2 space, 3 spaces. So next would come 4/3, and then 5/3. And sorry if my drawing in between is confusing. I'll go over it with a different color after I'm done filling in the rest of the numbers. And then 2 equals 6/3. Look at it again. 6 divided by 3 is 2. I'll draw my 2 lines here. And this would be 7/3. Oh, sorry. And then this last one would be 8/3. And 3 is 9/3 for this. And again, take the top number. 9 divided by 3 is, boom, 3. Okay, and that's supposed to be an arrow, but it did not work out. Okay, like I said, I'm going to go over in a different color. So this is just the space in between. Okay, that's what I'm coloring in. You'd think by now that my skills with these digital marker things would be better. Obviously not the case, but that's fine. So for this one, if you go back and count your spaces in between to make sure that there's 3 between each whole number or each like number they gave us before we started, you could even go with 1, 2, 3, boom. 1, 2, 3, boom. 1, 2, 3, boom. Also, don't know why I use boom, but that's fine. I need to erase this to fill in number 9, so pause it if you need to. I'm going to clear it. Okay, and last but not least, we have number 9. So this one you had a lot more to fill in. Not like a whole lot more, but like more than number 8. So if 1/8 is here and 4/8 is here, I have to fit 2/8 and 3/8 in between. Well, why? Because I have to count 1, 2, 3, 4. Then between 4 and 7, I have to fit 5 and 6. 5/8, 6/8. Well, why? Because 4/8, 4/8, 5, 6, 7. Then my 1 equals 8/8, 8/8. And then I'm going to go all the way up to 10/8. So 1, 2, 9/8, and 10/8. Okay, so now we have finished 12/5. We're keeping this the same for like the rest of the year. Since you watched this video, you're hearing me talk right now. Have someone let me know that you watched it when you submit your work. Just add the little note in the comments, like some of you have been doing when you submit your math work, that you watched the video. It is part of your assignment, so you should be doing it anyway. It's like your assigned assignment tomorrow, like day 2 of the lesson. But if you watched on the first day, that's fine too. Just still let me know. And also, if you have a like, hopefully you have like either like some object in your house that you can also submit a picture of that's equal to like 1.5. So like if I'll post mine tomorrow, but like I'll post like 1.5 pieces of a candy bar or 1.5 candy bars. But if you can also like take a picture or figure out what 1.5 of an object in your house is, whether it's a banana, another piece of paper, like pillows, if you want to like put your arm where your half ends, that's totally fine. Just so you can see that like you can look at other things as 1.5 instead of just all of these number lines up here. Okay, so hopefully that made sense. I mean, it's not like you don't like have to do like the picture thing, obviously, but I think it would be fun to see what you guys decide you'll be measuring as 1.5. So that is all from me. Hopefully this helped. But yeah, so keep an eye out for 12/6, which will be posted soon as well. Okay, bye guys.